You remember we start with architectural design, correct? So you have gone through all the
Correct.
architectural as per Turkey's standard. Then you understand how to design the architectural space planning, and then after that we have seen the local codes and standards like green building regulations. Okay, then we have external design temperature like ASHRAE, how to read that
Yes.
external temperature for different spaces, and it depends upon the location, depends upon the altitude as well. Okay, and we have learned
Okay.
about building envelope. Like if you go to the carrier software, there is a conduction, convection, and radiation. Okay,
Yeah.
there are three different equations for the calculation, and the building envelope which comes in basically conduction, right?
Yes.
Okay, so we have seen that how that based on the U value, how to calculate the heat through the wall, through the floor, through the roof, everything we have seen. Okay, then also
Okay.
there is a lighting power densities in the ASHRAE. Like for example, each and every space, what is the expected uh, lighting power densities? Like what is the watts per square meter you have to consume as per ASHRAE 90.1.
Yeah.
Okay, so these are the international standards which is required for us to design the heat load calculations. Okay, and then also we have, before we go to the heat load calculation, we have studied the basics. Like I have sent you all the videos. There are 20-25 videos about properties of
Yeah.
fluid, heat transfer method, air conditioning system design, and also there are some study materials which I have shared in the group. Also you can go through step by step. Okay, and then
Yes.
we also study the psychometric design. So psychometric design, I showed you uh, the carrier video, okay, which we have seen step by step. There are like 2 hours video, correct? Each and every
Yes.
module 1 and module 2, it will give you the detailed procedure like the air conditioning process. Okay, like you will learn about what is the ideal temperature, what is wet bulb temperature, relative humidity, enthalpy, then bypass factor, on coil temperature, off coil temperature. Okay,
Correct.
also you will learn about apparatus dew point temperature. Okay, and what is sensible load, what is latent load. Okay, then after that we come into the HAP thermal load calculations. So for the HAP thermal load calculation, I will share you one video, carrier HAP building simulations. Here you will
Yeah.
find step by step like how to create the file, whether project library, space, systems, run, model. Okay, you also can go through step by step here. Okay, like how to
Y-
enter each and every menu, like every how to open the project. Okay, how to enter weather
Yes.
properties. Okay, and if you go further down, how to upload the locations, the weather properties. Okay, then go to the space, enter the new schedule.
Yes.
Okay, here
Correct.
there how to enter the occupant. So here and all I'm not sure whether you have used this and all not in your
This.
day-to-day activities, right? Have you used this one
Yeah.
before?
Yeah. This one, engineer. The no. This one I've never used this one.
Yeah, this is
But
based on the occupant. This is based on the occupant loading. See, you cannot say that the occupant will be there in the space for 100%, right? Sometimes you will find
yes. Yes.
50% occupant. Sometimes you will find no occupant. Sometimes you will find 100% occupant.
Correct. Correct.
Okay, so this video will
But
helpful for you how to operate step by step.
okay. But normally, engineer, for this one,
Yeah.
um, normally, we're selecting 100%, right?
No, it doesn't mean like that. See, for example, you're designing for your office building, for example. Okay,
No. Okay.
some of the office building you will not find people 100% all the time. Say for example your office open at 8 o'clock. Okay, so
Okay.
you may have a 1 3 or 4 people in the office. Okay, and you can see
Okay.
that 9 o'clock you will have a 10 people. Okay, and
Okay.
say for example 50% of people will be going for business or going to outside, or some people will be on leave. So you will not have 100% people all the time.
Yes. Correct.
So
Understood.
based on the timing, say for example, after 6 o'clock, some people will go. Like you may stay like 10% people will extend their office time, or some people
Yes.
will go for business outside for sales sometime. So depends upon their office profile. Okay, sometime you will see that there are 10 spaces in the office building, but only 2 people will sit all the time. The rest of the 8 people will be going for outside for business meetings, client meeting like that. That will be their business strategy. So based on that, you can able to design. Okay, so you can
Okay,
design
okay.
with apply 50 percentage, 100 percentage like that. Okay, then when you go further down, this is for the occupant. See, 0 to till 7 o'clock, no people, because office building will not have any people. Then 7 to night 23, you have 100 percentage, for example.
Oh, mm-mm.
Okay, and if you go further down, see 7 to 8 o'clock, you have only 50 percentage or some percentage, 50 percentage only occupant. When 7 to 8.
Okay.
Okay, when you go further down, 19 to 20, like say for example 19 to 20, you will have only 75 percentage people.
Okay.
Morning
You mean
7
to
to
say,
8, you
engineer?
have, yeah.
You mean to say, engineer? This from 0012. This is from the 1 o'clock in the morning, right?
Yeah, 1 o'clock in the morning. So morning you will not have any people in the office, right?
Yes, correct. Yeah, yeah.
Because see, sometime what will happen, you will not switch on your AC in your office, right? It will be working all the time, 24 hours it will be working. Okay.
Yes.
So when you design your air conditioning load, you don't need to design for 100 percentage. Say for example, when you calculate for 100 percentage, you may get 10 kilowatt machine, for example, right?
Yes, correct.
But when you fine tune in this way, maybe you need only 8 kilowatt or 7 kilowatt machine instead of 10 kilowatt. Okay, so you
Yeah.
are saving 3 kilowatt, right?
Yes, correct. Correct.
Assume that you have 100 machines in your office building. There is a big retail office. Okay, there is a tower project, and you have 100 offices. So if you save 3 kilowatt in one offices, assume you have 100 offices, you may save 300 kilowatt, right? So you will save a huge capital cost.
Correct.
Okay, so that is why you are applying very based on the project conditions. Okay, and also if you go further down, see here, you have a profile, different profile. In the weekdays, there is no office, there is no working. Okay, like weekends, like Saturday, Sunday, you will not work. Okay, so
Okay.
for other weekdays, you have profile one, and weekend you have profile two. So you can apply in that way, so that you will save your operation. Like this will also helpful for you to calculate when you have a energy calculations. Like say for example, in yearly, how much energy is consumed. So that also you can calculate based on this particular profile.
Okay.
Okay, so
Yeah.
this is called
Get
hourly
get.
profile.
Yes. Yes.
See here, you can see design. Okay, so this is one means profile one. Monday to Friday, you have a profile one. Then Saturday, Sunday, and holidays, you have profile two, because profile two means no working, no people in the office.
Yes. Okay.
Okay, then you have a lighting. Similarly, for lighting also, you will not switch on light all the time, right?
Correct. Yes.
When you switch on the light, you have a heat dissipation from the light.
Yeah.
When you don't switch on the light, there is no heat dissipation. So that means, so it will calculate, your machine will calculate automatically based on your lighting profile.
Okay.
Okay, then if you go further down, this for the temperatures. Okay, how to set the temperature, schedule properties, like for example, occupant. Okay, see, for example, 0 to 23 hours occupied or not occupied. See, 0 hours, it's unoccupied. So you can also set the profile, whether people is occupied or not occupied. Okay, then
Ah.
wall.
Okay.
Then how to calculate wall U value? How to enter the U value?
Mm.
Okay, how to enter the window? How to enter that window values input?
Yes. Mm.
How to enter the
But
door
for the U,
values?
but for the U value engineer, normally the architect will give this one, right? And
Yeah, architect will give.
oh,
Architect will give, but also you also can get idea how to enter the U value, right? Based on
yes.
the
Yes.
properties. Yes, yeah, yes. You have to take the U value from the architect only. That will give you the exact value. But assume that you are in design stage, you don't have U value. How to calculate? You can use this design, right?
Okay. Yeah. I understand.
Okay, so this is a step by step. Step by step, you will get the how to operate the HAP software. Then go to the
Okay.
electric rate. Say, for example, this is for electric rates, or you can see different. For this, for energy calculations basically. Okay,
Okay.
and then you're going to spaces. Space, you will enter all the values here. You can enter the value,
Yes, yes.
all the values, height. Okay, then what is the type of the building, outside ventilation requirement, test space for the
In
lighting,
engineer,
occupancy.
yeah,
Yeah,
engineer. This people, these people.
yeah.
This is based on the ASHRAE or based on the furniture layout, right?
This is based on
Depends.
the furniture layout. Basically, based on the
Oh,
furniture layout. Because if
okay,
you go
okay.
take as per Ashray, you have to, it will give you more people. Okay,
Okay. Yes,
okay,
yes.
but when during the design stage you may not have furniture layout, so you can calculate based on Ashray. But when you do the detailed design, you will get the furniture layout, so you can calculate based on the actual furniture because it will give you the exact people.
Understand. Okay.
Okay, and here how to enter the wall properties like north exposure, what is the area, how to enter step by step. Okay, how to enter the value for the door, u value, windows,
Yes.
how to enter roof, how to enter the infiltration.
Engineer, this one, this air change per hour.
Yes.
I've read in one of your syllabus. Depends.
Okay,
This one, it depends upon the building construction, right? If it is tight, if
construction.
it is
Yes,
light,
yes, yes,
right?
yes, yes, correct. Have you seen that my
Okay.
design guide for the HAP?
Yes, yes, I saw this one.
Yeah, so based on that you can able to enter the value, depends upon the building construction. Okay,
Okay. Yes, yes.
then if you go further down, you will enter the spaces, default space. Okay, and how to enter ventilation air.
Yes.
You can calculate cooling. If it is a heating, how to enter by what type of heating you are using, electrical resistance or fuel oil, what is the type of heating you are using. Then cooling. Okay, then your fan,
Okay.
supply fan, how to enter. So it will give you step by step detailed video, then how to get the result. See how to get the result, then how
Yes,
to
yes.
read the result, everything.
Mm-hmm.
So if you watch this video, you will get a clear understanding how to operate HAP software, because otherwise you may operate HAP software, you may already operate the HAP software, but this will give you the step by step procedure as a
On how?
as how to say that, it is based on the career. Okay, they will explain you how to operate HAP software step by step, and each and every menu, what is the meaning of that menu, right?
Okay. Yeah. Correct. Correct.
Okay, so this will give you a full idea how to operate the HAP software. Then once you know how to operate the HAP software, I hope you remember this one you have studied before, right? This is the
Yeah. Yeah.
cooling load calculations by manual. Okay, so remember before we have seen that if you go to, for example, for this equation Q equal to MCB delta T, right?
Yes. Yeah. Yeah.
And if you go further down here for the roof, how to calculate. Okay, so see that
Yes.
u value you're calculating from the architectural, based on the architectural you will get the u factor, right?
Yes.
So this cooling load temperature difference between outside and internal. Okay, and also the
Correct.
area. So this is what you are entering in the HAP software. Okay, so
Okay.
if you go to the HAP software, can you see the result here? You will have a sensible load, you have a latent load, right?
Yes. Yes.
So if you see this one, this roof load is basically sensible load.
Correct.
Okay, so this sensible load from the roof, if you go to the video, you will find roof here, transmission. Can you see the sensible load?
Yes.
So
2000,
this much BTU per hour,
21,800.
this much BTU per hour. Okay, and here
Okay.
it is in kilowatt. This value is in kilowatt.
Okay.
Okay, that is just a unit conversion, correct?
Sure. Sure. Yeah. Correct. Correct.
So you know how to calculate this. Even the HAP software, how it is calculating? It is calculating based on this particular equations. U A CL delta T. So you are already giving U
Yes.
value, you are already giving the area of the roof, you are already
Okay.
giving the
Mhm.
cooling load temperature difference. What is the outside temperature difference? What is the outside temperature and what is the internal design temperature? What you need? You want 24 degrees Celsius or 20 degrees Celsius or 18 degrees Celsius, you
Okay.
can give the internal temperature. And what is outside temperature? It is depends upon the external location. Maybe you are in Dubai or you are in London or you are in Philippines, wherever you are. It will take
Correct.
automatically from the outside temperature. So it will give you what is the
Mm.
temperature difference, correct? So based on
Correct.
that,
Correct.
it can calculate the sensible load.
Okay.
Okay. Then
But
if you
engineer,
go
this
further
one.
down, yeah,
Last time we talked about this ASHRAE climate data, right?
yes, yes.
This one, engineer, for example, I can use this one even in our country, or maybe if in our country, because this one I don't know because I used to work only here. If there's any guidelines that our country will provide, that one I need to use, or this ASHRAE.
No, no, go to ASHRAE because each and every guideline, see ASHRAE, if you go online, it is up to date. Okay.
Yeah.
Like you will get all the values. But if you go to, say, for example, I will tell you one example. If you talk about UAE, Dubai, okay, it will tell you that you have to use 46 degrees Celsius, correct?
Yeah. Correct.
But if you go to ASHRAE, it is updated as per local condition. Now it is not 46 actually. It is actually like 48 or 49 degrees Celsius. Correct. The temperature
Yes.
what you are seeing in the newspaper or in the uh, in the social media, you will find they every time they telling you that the maximum temperature today is around 51 degrees Celsius or 50 degrees Celsius or 48 degrees Celsius. Correct. So that is a real
Yes. Correct. Correct.
scenario. So if you go to always using the ASHRAE, the online software, it will give you the up to date.
Correct. Yes.
Okay, so try to use
But
ASHRAE. ASHRAE, yeah.
but for example, engineer, if I calculate this one now, for example, in Dubai, so I need to use
Okay,
the reference giving by the Dubai, or what?
yeah,
This
it's
46
reference
degrees
given by,
tribal.
yeah, reference given by Dubai. Yes, 46 is the actual tribal temperature, but you can take more than
Yes.
also. As per ASHRAE, you can take more than that. You can design it because see, for example, if you talk about your air conditioning machine, okay, it is life of the
Okay.
machine is like 10 years, right?
Yeah. Yeah. Mm.
Okay. So what will happen after 10 years? What will happen? Your machine will start derating because the temperature keep on rising. If you talk
Yeah.
about 10 years before, the temperature of in UAE maybe 43 degrees Celsius or 44 degrees Celsius. But today we are up to like 50 degrees Celsius. That is what everyone is talking about global warming.
Yeah.
Everyone is talking about green building because they want to keep city in green. Okay, so that your temperature will not go high. That is what everyone is talking recently. Correct. Okay,
Correct.
but
Correct.
actually, what will happen after some time, maybe 2030, you may see the temperature is like 51 degrees Celsius or 52 degrees Celsius. So your machine will not be capable to work at that time, right? It will be derated.
Yes. Yes. Correct.
Okay, so that
Mm.
is why normally whenever you see the critical building like a hospital or data centers or some server rooms, what they will do, they will take last 20 years what is the worst temperature, like what is the 50 years last 50 years what is the worst temperature, correct?
Correct. Correct.
So they will take based on that temperature they will design the air conditioning machine. Maybe it will be 50 degrees Celsius or 49 degrees Celsius like that.
Okay.
Okay,
But in your
so
current project, engineer, you're using the same, this 46?
no, we are using as per ASHRAE.
Actually, only. Okay. Okay.
Yeah, ASHRAE. Okay, because some consultant they will take as per 46 just to save the cost, but in reality, it is not about the cost. Okay, for the critical building,
This.
you cannot go as per the cost. You have to take for the property. Okay, if it is a critical like hospital, you have to design for the human comfort. Okay, it is not 46. Actually, it is 41
Okay.
or something like that. Okay, 40, 51, something
Okay.
like that. So for the critical building, they will go as per ASHRAE condition for the current temperature, current weather data. But if you go for the normal building, like residential building, or if you go as per commercial building, you can go as per Dubai municipality because you will not have a 100 percentage load in your building, right? Say for example, you have a residential building, but how many people are staying in the residential during afternoon, right? Everyone will be in the office.
Yes.
Okay,
Okay.
but if you go
Okay.
to office, in office you will not have 100 percentage because some people will go for meeting. So there also you have a diversity factor.
Okay, the one we
Yeah,
you
in
showed
the
me, right?
occupant profile. Yes. So you
Okay.
can, if you go to this particular document, you know all the equations here. Okay. So the same equation you
Yeah.
are going to apply in the HAP software to get all the sensible load, and you are going to get the latent load. Okay.
Okay. Yeah.
So your summation of all the sensible load and summation of all the latent load will give you the what is the total air conditioning load here. Okay.
Okay.
And also you have a supply fan load, you have ventilation load, you have a return fan load. See, for example, if you have a motor, inside the motor dissipate heat, right?
Yes.
So that heat also you have to consider when you do the when you design the air conditioning machine.
But this one, engineer, how can I get this one from the
From the
submittal
ASHRAE,
like this?
from the ASHRAE for the this much of heat
Okay.
dissipation, for this much of heat motor capacity, you will have a this much of heat dissipation.
Okay. So, for example, okay, okay, I get it, get it.
Okay. See, sometimes what will happen whenever you give your whenever you do the selection of the machine. Okay. Normally, that heat load will be considered by your equipment manufacturer. Sometimes, say for example,
Yes.
you are telling your equipment manufacturer, I want 100 kilowatt machine. Okay. But he will not give you 100 kilowatt. He will give you 110 kilowatt. So what is a 10 kilowatt? That is a motor load.
Okay.
So that
Ah.
safety factor, they will give you the tolerance.
Okay.
Okay,
Okay.
so that is what whenever you design the machine, see for example, you are preparing the equipment schedule, you will mention everywhere 10 kilowatt. But when you see the selected machine, they will select for 12 kilowatt. Why the difference? Because they will take that manufacturing tolerance.
Okay. Yeah.
Okay, so that is what you can see the duct heat gain, you can see that supply fan load, ventilation load, return fan load, all will be calculated when you design the air conditioning. Okay.
Correct. Correct. Understand.
Yeah, so I request you to watch this video to get more idea how to operate HAP software so that you will thorough in HAP calculations. Then after that, you can practice some of the 2 to 3 buildings. I will give you some exercise. Try to practice and get the result.
Okay.
Then we can discuss in detail. Is that
Okay,
clear?
engineer. Yeah. Yeah, clear. Clear.